Section 9, we're talking about multiplying a whole number by a mixed number. Up until now, we've just done fraction times fraction, but let's talk about what happens when we have a mixed number, something that looks like, 2 and 3/4, where we have a whole amount with a fractional amount. Okay, so we're going to use a property called the distributive property. So you've been using the distributive property without probably knowing what it was called. So let's do a quick remember. How would you use mental math to figure out a problem like 7 times 21? Well, you might break up the 21 into 20 plus 1, and then you would multiply the 7 by the 20. 7 times 20 is 140. And then you would multiply the 7 by the 1, and you would get 7. And then you would add these two together, and you would get 147. That is the distributive property. You're taking a number, and you're distributing it over the parentheses. The 7 gets multiplied by the 20, and the 7 gets multiplied by the 1, and then you add them together. That is the distributive property. We call that the distributive property. You've been using this without really knowing what it was called, probably. So how are we going to use a distributive property with a whole number and a mixed number? Well, there are two methods that we are going to talk about when we're multiplying a whole number and a mixed number. Two methods you can use. The first method in this video is the distributive property. The second method, which we'll talk about in the next video, is when we change the mixed number to an improper fraction. We'll get to that one later. But first, let's talk about using the distributive property. We have a couple of examples here, and in this video, we're just going to do this column, practicing using the distributive property method. In the next video, we'll do the improper fraction method. So for the first example, we're going to multiply our whole number, 6, by our mixed number, 3 1/5. Okay, well, the distributive property says that my whole number, 6, gets multiplied by the 3, and it is also multiplied by the 1/5. Every part of this mixed number, my whole amount and my fractional amount, will get multiplied by this. So how that looks like, I'm going to multiply my whole numbers together, 6 times 3, and then I'm going to add to that my whole number times my fractional amount, 6 times 1/5. Okay, so wholes, and then my whole times my fractional amount. Okay, well, let's go ahead and simplify this. 6 times 3 is 18. And then I'm going to go ahead and put my 6 over 1, so I have the numerators and my denominators match up. And I'm just going to multiply straight across. 6 times 1 is 6. 1 times 5 is 5. Okay, well, I have an improper fraction. I need to change this back into a mixed number so that I can add my numbers together. I still have that 18. Changing this into a mixed number, well, let's see, how many times does 5 go into 6? Well, it goes in one whole time. And if I take out one group of 5 from 6, I have 1 left over, because 6 minus 5 is 1. And then my denominator stays the same. So 6/5 is the same as 1 1/5. Okay? Last step, I am going to add my whole amounts. 18 plus 1 is 19, and then my 1/5 just stays the same. So 6 times 3 1/5 is 19 1/5. Great, does that make sense? Well, I have 6 times a little over 3. Well, 6 times 3 is 18. I should get a little over 18. Yep, I got over 18. Let's go ahead and do 5 3/8 times 9. Now notice in this case, my whole number is after my mixed number, but we're still going to do the exact same thing. Every part in my mixed number is being multiplied by my whole amount. So my whole, my 5, is going to be multiplied by 9, and my fractional part, that 5/8, is going to be multiplied by 9. So here we go, and there we go. So I have going to have my 9 times my 5 I'm going to multiply my whole, and I'm going to add to that the 9 times the 3/8. Okay, now let's go ahead and simplify this. 9 times 5 is 45. And then I'm going to go ahead and put that 9 over 1, so I have whole, numerators and denominators. Let's see, I'm going to multiply straight across. 9 times 3 is 27. 1 times 8 is 8. Okay, so now I have an improper fraction. I want to change that back into a mixed number so I can add it to that number over there. My 45 still stays the same. How many times does 8 go into 27? You could do this mental math, or some of you might like to do it using long division. This is 27 divided by 8. How many times does 8 go into 27? It goes in 3 times. 3 groups of 8 is 24, so we'll take out that 24. We're left over with 3. This is my numerator, this is my denominator. So it goes in 3 whole times. 3 over 8. So 27/8 is the same thing as 3 3/8. Now I can add my whole numbers together. 45 plus 3 is 48, and then my fractional part is 3/8. We'll smush that in right there. 4 times 11 and 5/12. Okay, we're still using our distributive property, so my 4 gets multiplied by my whole amount, and my 4 gets multiplied by my fractional amount. Let's write that out. 4 times 11. Add to that 4 times 5/12. All right, let's go ahead and simplify. 4 times 11 is 44. And I'm going to put that over 1, so I have my numerators and my denominators. Now, you could go ahead and multiply straight across, and you would get 4 times 5 is 20, and 1 times 12 is 12. However, I'm going to go ahead and see if I can simplify first, because that's going to make my life a little bit easier, especially when we get into some bigger numbers later on. Simplifying, let's see, I'm taking a look at if I have something in my numerator and denominator that play nicely. 5 and 12 don't play nicely. 5 and 1, yeah. Ooh, but 4 and 12, I can divide by 4/4 because they both have a common factor of 4. 4 divided by 4 is 1. 12 divided by 4 is 3. I'll put the 3 over here. Now, when I go ahead and multiply, I have 1 times 5, which is 5. And I have 1 times 3, which is 3. So I could have gotten 20/12 or 5/3. Notice if you multiplied straight across and got 20/12, you still could have divided by 4/4. 20 divided by 4 is 5. 12 divided by 4 is 3. You're going to simplify one place or another. I just like to simplify before rather than after, if I can. Okay, now we have our improper fraction. Let's change it to a mixed number. 44 is still the same. How many times does 3 go into 5? Well, it goes in 1 whole time. I'm going to take out a group of 3. 5 minus 3 is 2. And then my denominator stays the same. Okay, so 5/3 is the same as 1 and 2/3. Now let's add our whole numbers. 44 plus 1 is 45, and then 2/3 stays the same. There we go. So 4 times a little over 11 is going to be 45 and 2/3. Now it's your chance to go ahead and try. Let's see what you can do with 5 and 1/6 times 12 using our distributive property. Pause the video and then check back in and see if you get it. Well, that one was nice. That one went ahead and simplified to a whole number. Didn't even have to change that back into a mixed number. Let's go ahead and do a word problem. Let's see, to prepare for weight training, Grog eats 2 1/4 pies 3 times a day. So each day he's eating 2 1/4 pies 3 times for 1 week or 7 days. How many pies in total does Grog eat in that week? Oh my goodness. Well, the first thing I think I'll do is I say, how many times is he eating pies? Well, he's eating them 3 times a day, and that's for 7 days. So he is eating pies 21 times. Oh my goodness, that's 21 sessions of pie eating. How many times each session is, how many pies is he eating? 2 1/4. So the problem we're doing is he's eating 2 1/4 pies, and he's doing that 21 times. That's a lot. Now, how many of us would have been tempted to maybe just multiply this by 3 and forget about that that's not 7 days, that's only 1 day? A few of us. Or we might have multiplied it by 3 and gotten an answer, and then multiplied that by 7 and gotten an answer. I think it's a little more efficient just to do it all at once like that. Okay, well, here is our problem. Let's go ahead and use the distributive property to multiply this out. And always remember our units. What are our units? How many pies? He's eating 47 1/4 pies. That week, Grog eats 47 1/4 pies. Wow, Grog, that's a lot of pies.